Well, thank you very much for a very kind introduction, and I'm really grateful for the organizers for this very kind invitation for me to talk about thulium laser from the perspective of a developing country in this fifth expert stone disease and 14th IUS meeting. So over the past 2 decades, we have been grown on the idea that holmium YAG laser is the workhorse of urology, not only for soft tissue, but also for urolithiasis. And to our experience, it has been a wonderful gadget that the urologists have, and they're able to do a lot more than what they used to do with pneumatic lithotripsy and ultrasonic lithotripsy devices. We know that holmium YAG laser is a pulse laser. It's a solid state pulse laser. It's in the invisible spectrum. It's infrared with a wavelength of over 2100. The quartz crystal of holmium YAG are excited by the flash lamp. It is strongly absorbed by water. The thermal injury zone is 0.5 to 1 millimeter, so that provides a safety zone. It works essentially by photothermal as well as thermochemical mechanisms. And the photothermal results in laser energy absorption, chemical decomposition, and ablation of stones. And the thermochemical mechanism essentially works by vaporization of water inside the stones. And as a consequence, what happens that the stone bursts from inside. So essentially a combination of these two, and it has been working well. And with the recent introduction of the MOSIS technology, we were able to cut down the retropulsion significantly as well, which is important both in the ureter and the kidneys. Well, the new entrant in the block is thermal fiber laser. It is also in the infrared spectrum with a wavelength of 1940, and that's what most of the studies have been on, although there is a wide range of wavelength for thulium. The optical penetration depth in water is about 4 times shorter than holmium YAG. So it would work closer and it would not have significant impact beyond 1 millimeter. And it has 4 times lower stone ablation thresholds. So essentially, it is a more powerful laser with pulse frequencies of up to 2200 hertz and very low to very high pulse energy. So it can be as low as 0.05 to 6 joules. It is a very long pulse duration, so it essentially provides more of a continuous sort of laser with 200 microseconds and up to 12 milliseconds. Total power of up to 55 watts, which is more than enough for urolithiasis. The stone ablation efficiency is 4 times as much. So when we had such a wonderful laser, why we needed another one? And is it going to beat the current gold standard, which is essentially holmium YAG? However, holmium YAG is a huge machine. It's a heavy machine. It's built in such a way that it produces significant amount of sound as well because of the water cooling system. And in comparison, the thulium is a much smaller unit, is 1/8 the size. It is only 30 kilograms. The Olympus Optima, Soltive actually, and it can be plugged to a wall socket. So it doesn't require specific electrical connections. So is thulium going to become the new gold standard? Well, With a peak power of 500 watt. It emits very small pulse energies of 0.025 joules, which again is important, and I'll show you how. Going up to 6 joules, so you can use it for fragmentation as well, with a frequency of 200 hertz. So it all translates into the Thullium fiber laser ablates twice as fast in fragmentation and 4 times as fast for dusting. This gives it a much higher ablation efficiency, and it produces a much finer quality of dust, which would flush out rather easily, rather than leaving 0.2 mm fragments, which sometimes become very irritating, and you find the CT scan post-operatively, even at 1 month, showing some small fragments, and that's to the dismay of our patients who are really not happy with seeing those small stone fragment. Another added advantage is that it reduces stone retropulsion. So if you look at the machine specification, one can appreciate that rather than the flashlight excitation of the quartz, there is electronically controlled laser diode providing constant peak power of up to 500 watts. The same pulse energy range as any high power laser like holmium, which is 0.2 to 0.26 joules, but for a 120 watt laser, and then very low pulse energy as well, which is 0.025 joules. So it's really quite low, to 0.1 joules. It has very low pulse energies. So that's again a big advantage. Pulse frequencies of up to 2400 hertz, very long pulse duration of up to 50 milliseconds. And the machine itself is several times smaller. It uses quite air cooling mechanism rather than water cooling mechanism, which takes all that sound away from the operating rooms that we are so used to now. There is reduced energy consumption, so again an added advantage, and it can be, as I've said, plugged to a wall socket. One of the concerns that were raised in the initially when the Thullium laser was introduced is about the thermal effects of Thullium fiber laser. The Thullium's high absorption coefficient in water equals high temperature. That was the observation. The heat production of 1 joule of TFL energy is 4 times that of holmium YAG laser. So essentially, the initial authors believe that this may translate into a much higher temperature rise of the fluid around the stone in the collecting system and in the ureter, which can be to the detriment of particularly in the ureter and can result in strictures. However, subsequent experiments and studies have shown that it is not correct, and there is no amplified temperature with the use of Thullium fiber laser. And the thermal safety precautions are used, so it is as similar to the holmium YAG laser. However, for high power settings, without appropriate irrigation, dangerous temperature rise are observed. And it's important that we are cognizant of this fact. So if we're using high power settings, we need to really be good with our irrigation, and particularly using cooler irrigation fluid to keep the temperature within limits. The Thullium laser fiber are smaller. So the smallest fiber with holmium is essentially 200 microns. So we have much smaller fibers and the smaller fiber means that they can provide and they leave some space in the working channel of the ureteroscope, which will allow some irrigation fluid to go through as well. They're more flexible, and the flexibility is extremely important because even with the 200 micron fiber, it is not possible to bend your scope, particularly in difficult angles, particularly in the lower pole calyx. to be able to fragment stone in that location. So you sometimes have to relocate your stones to pelvis or upper pole calyx in order to do fragmentation, because there's significant bending effect on the scope, which can actually damage the scope as well. Its resistance to bending has another added advantage, that the microfractures, which can lead to firing of laser within the scopes and can cause micro damages to the inside of the scope, are also avoided, because it can bend without fracture, without any leak of the laser energy. Additionally, there is less burn back, and this obviously would improve the life of the laser fiber. Now, if you look at the laser fiber, which of TFL as and holmium YAG, the smaller fiber presents several advantages. I've said better scope deflection and accessibility, more irrigation and better visibility, less retropulsion. And if the scopes are miniaturized in future, I think TFL would be the laser of choice rather than holmium YAG, unless the holmium YAG laser fiber can be reduced further. So, well, all these properties, the important thing is that stone ablation efficiency is increased because of this. So the fragmentation is twice as faster than holmium YAG. Dust are 4 to 5 times as faster than holmium YAG. So which translates into shorter operating time, produce finer dust quality, which can flush out rather easily. And the dust and the residual fragments are much smaller than that of the holmium YAG. Additionally, there is reduced retropulsion and sometimes absolutely no retropulsion in the ex vivo studies that we have had access to so far. So clinically significant retropulsion at 1 joules, whereas the same thing can happen with 0.2 joules of holmium YAG. So 5 times better in terms of retropulsion than the holmium YAG laser. The other important quality, although they are both very well absorbed in water, holmium and thulium, at 0 millimeter, 100%, whereas if you move to 0.3 millimeter away, then the holmium YAG efficiency decreases by 37%, whereas that of the thulium fiber laser is only decreased by 1.7%. However, if you move 1 millimeter away, then there is still significant laser energy, which is reduced to 4%. However, it's almost no laser effect at 1 millimeter. So that adds to the safety profile of laser as well as decreased retropulsion. Well, availability is an issue. And if we look at the market at the moment, Russia was the first place where thulium fiber laser was experimented and approved. There were some initial, all the initial studies also came from Russia. FDA approval was obtained in 2019, whereas the CE mark was approved in 2020. However, thulium fiber laser is still a rarity in most urological departments, even in the United States, Europe, and more so in the developing world, except India, where it is available to the best of my knowledge. So what about this new kid on the block, acceptability in the developing world? Well, since there is paucity of studies and there are few RCTs, the ratification of excellent preclinical findings are there. They have to be ratified by these clinical studies. So more RCTs with head-to-head comparisons with the current gold standard, which is HOYAC, is required. although there is an advantage that it's lightweight and easy transportation, which is, I think, important from the perspective of developing countries where you'd really need to move your laser machine from one place to another. However, there are issues with capital cost and maintenance, which needs to be looked into. So essentially, if you have a new technology and the new technology is cost effective, and it has clinical effectiveness as well. Well, if the clinical effectiveness is low and it is cost effective, then it can be discarded. However, if the new technology is the cost of new technology is less or low, and I think thulium fiber laser probably is, effectiveness of the new technology is more, then it should be adopted immediately. So I see a future of thulium laser in the developing world as well. And it's all because of all the properties that we have talked about, and probably with the cost factors taken into consideration, I see a promising future for thulium laser. Thank you very much for your attention.